evening, everybody. My name is Timothy Lager, and together with my peers, Sahil, Vora, and Yang Guo, we're going to talk about some applications of nanomaterials. I'm going to begin talking about some applications you might be wearing or you might see at home, and then Sahil will be talking about some in the automobile industry, and Yang will talk about some in cosmetics and some biological applications. So the first application I'm going to talk about is how the textile industry is able to create this kind of waterproof cotton. And what they've done is they've mimicked a phenomenon known as the lotus effect. And the lotus is a plant found in Asia. And people notice that when water lands on this plant, the water tends to beat up and roll off and not actually wet the plant. And originally, I think this was just basically attributed to the wax, but they actually found, when looking at the leaf on the nanoscale level, that the size of the wax particles on the nanoparticle scale actually really limited the surface contact between the water particles, which made the water immediately beat up. And they replicated this in the textile industry by coating fabrics. Well, first of all, the two companies that do this is Nanotex and Green Shield. And Nanotex obviously worships the word nano. They sell their products by the word nano. They give it positive connotations, and Green Shield tries to take more of a natural look. They really try to push that they don't really use a lot of nanoparticles and it's safe for you. And Nanotex didn't really give me any information on how they do this to their clothing. And a couple of videos they actually say that they modify the cotton itself, which I don't think is true. Green Shield, on the other hand, tells us that they coat their products, their textiles, with these silicon nanoparticles, which kind of give it the roughness that you see with the lotus plant. And then on top of that, they put fluorocarbons. And these fluorocarbons are lipophobic and hydrophobic. So that kind of gives you like a stain repellency. And it's actually the silicon nanoparticles that provide the limited contact area for the water droplets, as well as this kind of air field around that provide the super hydrophobicity that you kind of see when you now wear a coat these days and you don't get wet in a rainstorm. And they basically work with all other companies like Levi and North Face, and they help waterproof normal cotton. I have a short video that kind of shows you what they're capable of now.
You've heard of better living through chemistry, but how about better living through nanotechnology?
Drying side, here we have 100% natural cotton, and we've actually changed it to the molecular level. So when I put water on the inside of drying side, and it soaks in, what you'll see is the moisture moves to the outside of the fabric, but the inside of the fabric stays dry. So it now makes for a much better...
So basically in this video, I would assume that they applied this to the front of it, and they actually have to apply pressure in order to make the water kind of diffuse through the fabric, and the outside hadn't been treated, and that's where the moisture kind of stays. So the second application I'm going to be talking about is the sock over here. I'm just going to quickly talk about how these days they seem to be coating everything with silver nanoparticles, and silver nanoparticles have been shown to have like disinfectant properties. They kill fungi, bacteria, and even viruses, since viruses have to almost breathe during their reproductive cycle. So all three are blocked, their respiratory functions are blocked by silver nanoparticles and they're killed. So now they're coating socks, keyboards, medical equipment, all sorts of things in order to kind of push this, push that they're disinfecting these products. I'm not really sure how well it works. I haven't tried the socks myself. But there's a lot of negative media associated with these. I'm not 100% sure why. People are worried that they are going to damage the washing machines, or maybe they're that bad for the human body. They absorb through the skin, or people inhale them in some way. The truth is, silver nanoparticles are not actually that bad for human beings in small quantities, but there's still, if you type in antifungals, silver nanoparticle sucks, 3 out of 5 hits are negative for no scientific reason. The last application I'd like to talk about is this picture up here. You can see it looks like they're called, it's a product by Pilkington Glass. They're called self-cleaning windows. And I have a quick video to show you basically how they explain it works. It's not very scientific, but it's what they show the public. So. not sure why there's no sound. You can maybe read. Basically, they're saying that there's organic material such as dirt and pollen on this window. The sun comes by and heats it up. All the organic material breaks down, and the water washes it away. And that's all they really tell you. But if you do some research, you find out that the reason for this is that they coat their glass in titanium dioxide nanowhiskers. And these titanium dioxide nanowhiskers have two important properties that contribute to this. The first is that they are photocatalytic. So when UV rays or light, when under UV or visible light, their electrons become excited, and they assist in oxidizing a substrate. And in this case, that would be organic material. So your pollen or your dirt would slowly be broken down by these oxidation reactions. And then the second property that kind of gives you this effect is the fact that they're extremely hydrophilic. And basically, you get a really low contact angle, and they say that this property kind of helps wash away that dirt instead of sitting on your window.
Okay. So one of the paradigms of the 21st century is that all of our gadgets are dramatically lighter or powerful or more energy efficient, and nowadays everyone wants to make everything smaller. But this hasn't really happened with cars as such. So the basic problem in cars is that I'm going to focus on three main issues in the automobile industry where they've used nanomaterials to improve properties. So the first issue is this beautiful car here, which you can see. So this is being developed by German researchers at University of Dresden in Germany, and basically this is an electric car. So it works on electricity, and it's a sports car. So this car can reach speeds of 143 miles an hour, and it has a horsepower of about 500 horsepower in this car. And it's basically the reason why it can go so fast on electricity is because the entire body of the car is made mostly of carbon nanofibers. So carbon nanofibers are like 5 times stronger than steel, but they only weigh like a fraction of the weight. So it's really light. This car weighs about 900 kilograms, and most of the weight is because of the batteries. It's not the car itself. So the problem in electric cars is that the heavier the car is, the more the battery capacity that you need to run it a farther distance. This car can go up to 183 miles on a single charge capacity, which is much larger than existing electric cars that you have. And another application of nanomaterials in this car is that the charging time that this car needs is only 30 minutes. You just need 30 minutes to charge the full power. And how is this possible? It's possible because of the second application that I'm going to talk about. So this picture is basically work done at I forget the university, but it's basically a silicon wafer at the bottom, and this is a cross-sectional SEM view of carbon, aluminum, silicon nanoscoop structures. So they found this new term called nanoscoops. Now, why does nanoscoop? Because this carbon here is basically a carbon nanorod. Then you have an aluminum nanoscale structure deposited on the carbon nanorod. And then you have this ice cream scoop-like structure of silicon resting on top of it. So why do you do this? The thing is that when you have lithium-ion batteries, this is basically used in lithium-ion batteries. So when you have lithium-ion batteries, the anode